Okay, welcome back. Last lecture of the semester. Crazy though it has been. Most of you guys have turned in everything. I think a couple of you have maybe one or two assignments here and there, but by and large, you guys are caught up and doing well. Again, a reminder, all assignments are due no later than May the 10th. Okay, this is our last class. Grades do not have to be in until noon on the 11th, so just get them in on the 10th. That is a Sunday. That is basically just under 2 weeks. Excuse me. Now, got three chapters here. We're going to kind of hit the high points, and we'll let you guys move on. I know you guys are busy. So if you'll look on page 314, here we're going to go ahead and talk about ecology, and specifically population ecology. Now, this is my personal favorite part of biology. There, when I went in to major in biology, I got out of high school and thought I wanted to be a geneticist. That lasted right up until I took genetics and realized genetics is actually really boring. Ecology, you get to go out and mess with animals and get your feet dirty and all that good stuff. So, ecology, we love it. Okay, so here you see there a honking mess. And you see these geese overrunning in a park. Okay, these are Canada geese. Please note that they are called Canada geese. They are not actually Canadian geese. Okay, they're not going honk but there, this is an example of kind of saving a species from the brink of extinction that worked a little bit too well. Okay, their population was down to about 9,000 individuals in 1970. Today, there's over 300,000, and that's just in Michigan. Okay, guys, these things are flying rats, and plus that they're just mean. Okay, but they are what they are. And just the fact that they were able to come back from, the brink there shows that, we can manage species and their survival successfully. Okay, sometimes though you need to kind of balance the needs of the species against the needs of humanity and kind of strike a balance. Okay, now where that balance lies is often depends on one's political persuasions. I have my views, you may have yours. Okay. We'll just kind of leave it at that. Okay. Now you see the word or there, population, group of organisms of the same species within a defined area. And again, and there, that defined area, it can be pretty much however you want to define it. It can be, all the bacteria on this part of your screen, or it could be, the human race, all the people living on the planet, or anywhere in between. So the size, vary. It will suit your needs. Okay, and you see that word ecology there. Okay, ecology, that's from the Greek. Ology, of course, meaning the study of. Eco from their word oikos, which means house, is literally the study of our house. Okay, and that's kind of fitting here. So let's get into this. Okay, population and characteristics or demographics. Okay, the statistics that describe a population. Okay, the census going on right now. You'll hear that a lot. The census will ask various demographic questions. And again, guys, if you have not filled out your census online or sent it in your card or whatever, fill it in. It takes like 10 minutes to do with there, and it determines any number of things there. Representation and being, one of many. Okay. But, we got that plug out of the way. Okay. Various factors of population. You have population size, which is just the, just exactly what it sounds like. How many individuals are there in a species? How many are in that a population? Just how many are there? Population density. How spread out are they? Or how many in a given amount of area? Okay. Union County, we've got approximately 15,000 people living in Union County. Okay. 15,000 people who might be just, within a couple of city blocks in New York City. So New York is going to have a much higher population density, okay, than Union County will. Okay, so how many are there, or how concentrated they are as population density? Distribution. If you look at the top of 315, how are they all sorted? Okay, in nature, okay, most things here, they're probably going to be either clumped or random. Okay, uniform distribution, unless you have something like that middle picture where you got all the bird, or it's all clumped together there, or just like that, all spread out up there. Uniform distribution is really not going to happen a whole lot in nature. Random distribution, you have something like the dandelions, it's just where it's the wind blow the seeds. Clump distribution, they're all going to be gathered this place, this place, this place, wherever. And it's going to be based on the location of resources. Okay, so distribution is where are they relative to each other. Okay. Let's see. Age structure. That's the distribution of individuals among various age categories. Okay, and populations that have a lot of older members, those are going to tend to get smaller. Populations that have younger members in the prime reproductive years, those are going to grow. And we're going to talk about that in more detail here in a little bit. Okay. How can we collect demographic data? Well, that's going to depend on population size and, factors like how easy is it to get to them, that sort of thing. Okay, if the population is small enough, you can just do a head count. If they have heads, or you can, sometimes if you're studying bacteria, you can count colonies or something like that. Okay. If you have a bigger population, there are various methods of sampling you can use. Mark and recapture is a common method, and what you'll do there is you'll lay out a trap, you'll capture the individuals, you'll mark them somehow there, or you'll let them go, and then you catch a second batch. Okay, if you've got, if you catch, it's 100 individuals the first go around, you mark them, you number them 1 to 100. Okay, it's 100 individuals the next time, you've got 75 of individuals that you marked and counted the first time. You can conclude that it's a fairly small population. Okay, you catch 100 of the first time, you mark them, you release them, you don't get any of them back in the second batch. You conclude that it's a bigger population. You do it that way. And there are various other statistical sampling methods you can look at. Okay. Population growth, 317. Okay. Now, in previous years, I've had to go into a little more explanation about exponential growth, but okay, unless you've been under a rock there, I think we're all familiar with exponential growth right now due to current events. So I'm not going to talk about that in any great detail. Okay. Under ideal conditions, okay, in a laboratory, on circumstances where there's no known predator, or for an organism, you're going to experience exponential growth. Okay, it's just going to keep going. It's just going to go up and up and up. You get that J-shaped curve like you see there around 317, or on the nightly news. Real world. Things like climate, predation, resources, disease, all that good stuff, it figures in. You're going to get what we call a logistic curve. Okay? Your exponential curve is a J-shaped curve. Your logistic curve is going to be an S-shaped curve. That logistic curve is going to kind of take off. Okay, it's going to go straight up like this. S curve is going to go up, and then it's going to level off. Okay, and the point where it levels off, guys, if you have a curve, that is going to be your carrying capacity. Okay, that's the maximum number of individuals of a given species that environment can support. Okay, that's the carrying capacity. Okay, and that influences that. Okay, if you look on 318, you'll see there are density-dependent factors and density-independent factors. Okay, and you also have living and non-living factors that affect them. Okay, or of course, this is college, so we're going to call that biotic for living and abiotic for non-living factors. Okay, now abiotic factors would be things like climate, temperature, water, soil, all that sort of thing. Biotic factors, predators, prey, food supply, that kind of thing. Density dependent factors. Okay, is going to depend on the number of individuals in that population. Okay, if you've got 5 of insects, okay, and living in a forest, you've got a population of 5 in this entire forest. Food's not going to be much of an issue. Okay, if you've got 5 billion insects in this 1 acre or forest, food suddenly become an issue. So that's an example of a density dependent factor. Okay, density independent factor, that's going to be something that it doesn't matter how many there are in that population, it's going to affect them all pretty much across the board. That's got to be things like, usually it's never anything good. It's like a fire, flooding, something like that. Okay. Peanut Gallery is coughing over here. You okay? All right. And we have up here. Okay, we talked about those. Okay. Oh, good. Yeah. Life history patterns. This is fun. Okay, look on 320. Okay. There's a school of thought in biology, genetics, etc. It's called the selfish gene. And E.O. Wilson, who I actually got to hear speak several years ago, he's a main proponent of that. The idea is that genes themselves are going to act in ways that best further their propagation. Okay? And there's still a fair bit of controversy about this. It's a theory's been around for about 50 years at this point, but it's still sort of being debated. But, giving credence to that is just the idea of life history patterns. Okay? Different organisms are going to carry out how they live their own lives and how they reproduce according to different patterns there. Okay? And your type 1 curve, if you look at the bottom of 320 there, see that RAM. And some of your older books, guys, is you'll hear about K selection and R selection. Okay? And your type 1 curve would be an example of K selection. Okay? Well, you see there that most rams, or sheep, I guess you'd say, not all rams, that species wouldn't last very long, but the sheep there, bighorn sheep, they are going indigo, and most of them are going to survive into adulthood. And as they go along, as they start to age, they're going to fall off, but then going to be a pretty steep fall off as they get to a certain point of age there. They're going to fall off, but most of them are going to survive into adulthood. And what you're going to see there is they're going to have, over their lifetime, they're going to have probably fewer than 10 offspring. And they are going to invest a lot of time, a lot of energy, a lot of resources in raising those offspring. Those offspring, okay, that's why those offspring tend to make it to adulthood, is because their parents spend a lot of time and resources on them. Okay, so you're having fewer total offspring, but the ones you do have are very likely to survive. And your genes are going to pass on that way. In the middle, you've got your type 2 curve, like your lizard there, where basically just the longer they go, the less chances there are of survival. There's somewhere in the middle. Type 3 curve, what older books are going to refer to as an R selection. Okay, that is going to be something about the something like, think of oysters or some of these plants that you see. Okay, an oyster, fish, something like that, they are going to have thousands upon thousands of offspring. Maybe 10 of them will survive. Basically what happens is that egg gets fertilized, they get dispersed out into the ocean, or out into the wind, or whatever. They go out. That is the end of the parental involvement. There's no time or energy invested in them. Okay? We're going to pass on our genes by putting 1,000 out there, maybe 10 of them will survive. So that's your type 3 survivorship. Okay? Most of them die before or they're ever have a chance to even develop. Okay? Let's see. Okay. Getting into human and population. And this is kind of a scary thing here. If you look at the graph there on page 323, you'll see that here it took 10,000 years. Okay, there's there for us to reach 5 billion people. It took another or almost 2,000 years to reach 1 billion. Okay, but just within my lifetime, within 45 years, we've almost doubled the human population. Okay, the population hit 7 billion in 2011. And actually, here with the power of the internet, let me just pull this up real fast. Earth population. Okay, 7.594 billion, and that was as of 2018, so it's probably about 7.7 billion or so now. Okay, in other words, guys, since 2011, the Earth has added basically the population of the United States plus the population of Canada put together. Okay, a lot of people, short amount of time. And thing is, guys, that carrying capacity we talked about, maximum amounts of individuals of a population that an ecosystem or an area can sustain. People like to think that we are not part of the environment, but we are. Okay, we're animals. We are animals just as much as a dog, a cat, a horse, whatever you want to say. Okay, we had the same needs, we had the same factors that constrain in us. Okay, no one knows for sure what the carrying capacity of the Earth is as far as humans are concerned. Okay, now humans, we have I'm not going to say a unique ability to adapt, because you look at birds, look at bacteria, look at things like that. We're kind of middle of the pack, honestly, in as far as our ability to adapt is concerned. But we do have a lot of ability to adapt to our environment. We have probably the biggest ability out of anything in life to adapt the environment to us. And that has enabled us to increase the Earth's carrying capacity to a point. But with that said, guys, we don't know for sure what the Earth's carrying capacity is. And there's some people out there, guys, some that would say that we've already hit it. We've actually probably already exceeded it. Okay? Now, something like, if this comes along, you go, the carrying capacity is here. Let's get up here. Carrying capacity is here. We go up, we butt up against it, we pass it. It's going to be okay for a while. We're going to go, but then eventually resources are going to run out. We're already starting to see that with things like oil, food shortages in a lot of places. Okay, water resources are already starting to be limited in a lot of places, and eventually, guys, it's going to hit up here, and then it's going to crash. And it's going to crash hard. And guys, we don't know for sure where that point is. Okay? We may or may not have hit it already. We don't know. Okay? So, let's look. Okay. your age structure diagrams, 324. Okay. If you look at China, and China has actually had some success in controlling their population. China, I believe it's the second most populous country on earth. There's India and China. They up there, and I believe China has the most. I wouldn't swear to it. But if you look at the graph there, China, you'll see that China's got a fair number of young people. They've got a number of people of in their prime reproductive years, but they've also got a pretty substantial amount of older people over there. And you'll see there that large number of older people, that is actually helping their population decline. And what they did there from the 80s to about 15 years ago, China actually had a policy in place, the one-child policy. And that worked really well. I mean, they didn't, China, they've got a number of issues with their government and how they treat people over there, but, they didn't, kill people or imprison them or anything if they had more than one child, but they did have to pay some extra taxes. And this worked pretty well. It led to a reduction in their population. It actually worked a little bit too well. So I discovered my best friend was going through the process of adoption. Okay, if you adopt from China, you are almost certainly going to get a girl. Okay, in Chinese culture, having a girl, it's considered lower status than having a boy. And people figure, okay, if we're only going to have one child, we want a boy. So they would give the girls up for adoption. And this policy here actually led to a shortage of girls and then subsequently women in China. And with that, that's sort of what kind of led to the end of the one-child policy. So we'll see what happens with that. Now, if you look at India, okay, you see the overwhelming majority, okay, of their individuals are in their prime reproductive years, okay, and or pre-reproductive. The overwhelming majority of that population is a prime reproductive age. So India, they're experiencing a population explosion. If you look at the United States, we're somewhere in the middle. Okay, so there's that. Talk about humans and our abilities to modify the environment around us. Okay, it has it's a considerable impact on the environment around us. And when I've taught a human ecology, which if I ever get to teach that here, or I recommend that you get into, or take it with somebody else. It's an excellent course. Concept of the ecological footprint. That is how much damage or how much effect we have on the planet. And there are a number of things out there that will calculate that for you. In fact, when I teach human ecology, I have my students take that very early on. And it's sobering. I've taken that, and I'm taking this thing here, and I'm clicking in this box and this box, and I'm recycling over here, and I'm combining trips over there, and I'm turning lights off here, and I'm recycling some more or here, and I mean, and all sustainable, and I'm just so good, and I click for that get results button, and if everyone on Earth lived the way I do, we would need 2.93 planet Earths to survive. Ooh. Okay. Taught human ecology off and on for about 10 years now. And in all that time, guys, I have never once had anyone score under 2. Okay. I believe the record was 12. Okay. For the high end and low end, it was about 3.5. Okay. And, it's sober. And that just gives you an idea of what we need to look at. And here, things we need to be aware of. And we're going to touch on that and some more things here. We're going to talk about communities and ecosystems here in our next video. Stay tuned.